In this video, we will look at how we can use a microcontroller to control a motor. The way we're going to do that is by using an integrated circuit, specifically the L293D, which is designed to control motors. Here is the L293D. It is a chip. It has conducting material inside and many tiny circuits all embedded in it that has a specific task. This specific one can be used, as I said before, to control a motor. This one is a 16-pin motor driver, and when you examine it, you'll see that it doesn't have the pins marked, but it does have a little semicircle notch on one end, and this we will use to orient us when we're trying to determine which pin we're looking at, and that is what we'll consider to be the top of the pin. The top of the motor driver, that is. This specific integrated circuit can be used to control two direct current motors at the same time, and it can be done where the motors can move in either direction, either clockwise or counterclockwise. There's a spinning rotor on the motor, as is shown in this picture. This is the type of motor that we'll be controlling. You can see that on the right side there is a little axis that can rotate either clockwise or counterclockwise. And there are two wires that extend from this motor that we will connect to the L293D. The L293D can provide drive currents up to 600 milliamps in each channel for the voltage, a large range of voltages between 4.5 and 36 volts. We are going to be picking specific currents and voltages to work with for this application. And here is a chart that shows the pins on the L293D and what they are supposed to do. They each have their function. So you can see at the top of this chart, which is called a pinout, we see the notch that is the semicircular notch, and that again shows us where the top of this integrated circuit is. And then along each side we see the labels for each pin. And so we're going to go over what these various pins do and how we would connect them. Okay, so the pin 16 on the top on the right, that one is used to give power to the L293D. And so we will be connecting it to 5 volts on the Arduino. We also have a pin 8, that we used and we connected to the motor, and this will also be connected to 5 volts, and this gives power to the motor. There are 4 ground pins on this chip, and we have to connect all of them to ground if we're going to be using them. Pins 4 and 5, and then pins 12 and 13. Now, as I said before, this particular motor driver can be used to control 2 motors independently of each other. And if you recall, the motor that we looked at on the previous slide had 2 colored wires coming out of it. And for each motor, we would connect it to either pins 3 and 6 or pins 11 and 12 using those wires. There are a couple of things that we want to be able to control on the motor as we power it. One is the direction in which it spins, the axis spins. And we need 2 pins to do that for each motor. For motor 1, we'll need pins 2 and 7, and for motor 2, we'll need pins 10 and 15. Now, you might wonder why we need 2 pins to control the direction of spin. After all, there are only 2 directions in which we can make the motor spin. Well, the specific circuit that's inside the L293D is known as an Hbridge circuit, and it's set up so that we can control the direction of the motor spin as follows. One of the configurations inside, which has a total of 4 switches, is shown here on the left. In this specific case, the idea is that we would have the 2 pins marked in 1 and in 2 that we would connect to the Nano, and we would make it so that we sent a high signal to the pins And that would be fine if we wanted to send power through the Hbridge circuit. However, as you can see, if the switches inside are open, two of the switches are open in this configuration, there is no actual path through which current can flow from the high point at the top down to ground at the bottom. And so because those two particular switches are open, there is no power passing through. If you look at the center of this diagram, you'll see that's where the motor is. Okay, and you see there's no motion in the motor. So there are a total of 4 switches on this Hbridge circuit, and if the 2 top ones are open, then there's going to be no flow of current and no motion of the motor. Another way that we can connect this is to have the top left switch closed and the top right switch open, and the bottom left switch open and the bottom right switch closed. And in this configuration, there is a path that's shown in red where current can flow from the high at the top. That would be that there's a non-zero voltage that's placed there, and it can flow through the pin marked IN1, through the switch that is closed, and then through the motor. And because the motor is there in the middle, we expect there to be a voltage drop across that motor. There is a difference between the voltage at the high point and ground, and that difference comes across the motor, and it causes the motor to turn in a clockwise manner. So you see we have 2 open switches and 2 closed switches, and this particular configuration allows for clockwise rotation of the motor. Now we can also have this configuration where we have a high placed at pin N2, and this matches up with having the switch closed along that path on the upper right part of the circuit, and then the switch on the upper left part of the switch is open, of the circuit is open, and then further down in the circuit we have a closed switch on the left and an open switch on the right. And again, there is a path through which current can flow from the high voltage down to ground, and because of the direction it goes in, it does pass through the motor, and there is a voltage difference across the motor between the high and the low. We have the energy is placed there in the motor. It's used by the motor to make it turn counterclockwise. The last possible configuration is to have the 2 switches on the top closed and the 2 on the bottom open, and there is a path, but because there is a closed loop here and no difference in voltage between the beginning of the path and the end of the path, there is a closed loop here where the voltage is high at the top. In both cases, there's no change in voltage across the motor and therefore no motion. So we have these 4 different configurations. In each case, 2 of the switches are open and 2 are closed. So we see that we're going to want the 2 pins that we attach to that have to do with the direction that the motor turns in to be attached to digital pins, because we're going to want to set the pin to be either high or low depending on whether we expect the switch to be open or closed. And so in this configuration we have the case where there is basically we're going to set pin N1 and pin N2 to low. It will not be high, and that will correspond to these open switches, and there's no motion. In this case, we set pin N1 to be high and pin N2 to be low, and that will correspond to the switch positions that we see here. In the third case, we set pin N1 to be low and pin N2 to be high. And in the fourth case, we set both pins N1 and N2 to be high, and we have no motion of the motor. And so we can summarize this in this table, and we see that each case is listed here, as I said already, that when the voltage that's sent to N1 and N2 are both low, the motor will be off. When we have high and low respectively sent to N1 and N2, the motor will spin in the forward direction. Low and high, then the motor will spin in the backward direction. And when both pins are set to high, the motor will be off. So this is the scenario that we have where we can run 2 motors, and we've looked at the functionality of almost all of the pins. There's only a couple left that we haven't talked about, pins 1 and pin 9. So pin 1 is used to control the speed of motor 1, and pin 9 is used to control the speed of motor 2. And now we want to talk about how that works. We only have 1 pin to control the speed of a given motor. Now, speed control, we would like to have the motor speed be somewhere between 0 and some maximum value that's unspecified. It's really dependent, on how much voltage we have available. And so we're limiting it to 5 volts. I do not know how many revolutions per second that is. I do not know, but it's a fairly high speed that the axis turns. But we know that because this is an analog value, since we have a range of values, that we're going to want to have a speed specified using analog output. We'd like to have the nano send the specific speed that we want using analog write. We want analog output, and the way that we achieve this is by selecting a digital pin that supports pulse width modulation, and we connect that for the first motor to EN1. Now for the other motor it would be to EN2, which is pin 9. And because analog output, the output register that is used to express a value is between 0 and 255. It's because the register is an 8-bit register, and the maximum value in binary would be 8 ones in a row, which means 255 in decimal arithmetic. Okay, so when we want to just work with 1 motor, then these are the pins that we're going to want to connect. We'll need to connect all of the pins on the left side. We need to use pin 1 to control the speed of the motor. We'll use pins 2 and 7 to control the direction of the spin. We need to have the motor itself connected at pins 3 and 6. We need to connect to ground pins 4 and 5. Pin 8, we connect to the motor itself to give it power, okay, just directly that way. And then pin 16 is to power the chip. And the other pins we can leave open unless we decide that we want to connect another motor here. So, as I said before, the pin 8 is for motor 1. Pin 16 is for the motor driver. And then we want to select 3 digital pins. 2 of them are going to be for pins 2 and pin 7, in 1 and in 2, and they need to be digital output pins. And then the 3rd pin is also a digital output pin, and we connect this to pin 1, which is EN1. And this is a pin that we want to have support pulse width modulation so that we can send an analog value through this pin. And this is the connection we want to make to be able to use this DC motor. And so this is how we set up the chip, connect it to the Nano, and then the Nano, of course, has to be connected to the laptop, so we can use the Arduino IDE to do the programming for this. And that's something that I will explain how to program in an accompanying video.